Okay, so welcome. Some of you stayed, some of you exchanged. So different audience. Cool. Uh, this talk is something new for me. I'm usually trying to stick with technical topics and explaining technologies. This is more philosophical thing. So there are probably going to be some stuff that you disagree with, and that's fine. And let's get to it. So who am I, and why should you trust anything I say here? So I'm a hobby programmer for about 20 plus years, at least partly professional for 5 plus years, and I'm package maintainer for 10 plus years. So yeah, if you are from some enterprise, I might fit in some semi-senior whatever. So that's you shouldn't trust me because of this stuff. That's actually first claim that I make here. Your experience with doing stuff doesn't matter in terms of years. You can be somebody that is sitting at his desk and doing the same thing over and over for 20 years and actually don't get anything new and don't understand stuff. Or you can be bright new guy that gets everything in 1 year and have the good idea, have a good grasp of what's going on. So stating years of experience means basically nothing. So what you can base your judgment on? Well, listen what I say, evaluate whether it makes sense to you. If it makes sense, maybe it will help you. If you think it's nonsense, then discard it, disagree with it, and ignore it. That's fine. This is all subjective. But I hope that you will agree at least with some parts. Let me ask you, who of you is developing a software? Most of you? And who of you consider yourself some senior? Cool, some of you. And yeah, one more question, since we are doing some poll. Who of you work in big enterprises and who works in startups with freedom? So enterprise? Yeah, a few of you are here. Cool. So why did I mention package maintainership? And why is package maintainership anyhow relevant to software development? And also, one hint for those that consider themselves just entering the field. It's a good way to actually start your career. And it will give you quite some experience over quite short period of time. What you do as a package maintainer, you don't have time to learn everything. You don't have time to understand this huge pile of software to all bits. You have to live up with local knowledge, find the problem as fast as you can, and fix it. You can't spend 2 weeks reading all the documentation, all the source code. You can't basically get an overview of what's where. You just have to find the problem and fix it as fast as you can. It sounds scary, and in the beginning it might be so, but you learn to debug, and you learn to debug fast and to debug code written by aliens and crazy people and stuff like that. So that's really useful, because when later on you will have some clever ideas in your career and then you will have to debug it, and you will curse yourself, then it might be helpful to know how to debug alien code. Or sometimes when you get something from your coworkers later on. Sometimes it's crazy. So that's one part. Other great part is that you will learn that everybody makes mistakes. And even the huge software projects have really beginner's mistakes in them. And the outcome of that is you actually find out that you are pretty good yourself. Because in software that is used by millions of people and billions of dollars depend on it, there are mistakes that you would never, ever do, even when drunk. So it really boosts your morale and make you much more confident, which helps. So when we are trying to write software, first thing to consider is what problem you are trying to solve and try to solve that problem. If you are writing a mail client, it's good to start with something that can send and receive mails. There is one great example. It's called Microsoft Outlook. It can do calendar, it can do invitations, it can do contacts. It just sucks and sending mails. So if you are writing a new software, try to start with the main functionality that the software should have. Scripting is nice, but if you're new to do application, cannot track some items, it doesn't matter if it has greatest 3D engine out there. So try to stick with the main functionality first and extend it later on, and maybe later on you will find out that the functionality that you thought that was going to give it a really nice user experience is unnecessary. Is Agile still a thing? We have few guys from corporations. So Agile. There are plenty of competing ways how to do it. There are various trainings how to do it and stuff like that. So what's the good stuff about Agile? It's actually managers' approved way to release early and release often. Release early and release often is what you should do. You should write code that you think is solving the problem and give it to people that you are writing it for and test whether it is what they ask for. Quite often you find out that they didn't know what they wanted. That's the usual way, and that you can throw it and you have to start from scratch. That's what happens usually. Bad side about Agile is that, as I mentioned, managers found about it, and you can use it to make them to allow you to release early. But bad side is that they will use it against you as well. Because most of these Agile techniques require some meetups, and managers love meetings. So using Agile in a huge company will result in few meetings a day to make sure that you are still aligned and still Agile. It will give your managers excuse to actually not specify anything they want, because you are Agile, you will figure it out on the way. So just write the code and yeah, we have no idea what should it do, but write the code and tell me about it on the meeting that we have in 2 hours and stuff like that. And another point is that there is plenty of trainings available. So you will get trainings in Agile, and you will fold the airplanes and stuff like that, and try to learn how to do these meetings effectively, but your managers wouldn't do them. So they will still do the fast stand-up meetings that will take 2 hours. So be aware of Agile. Another interesting point is reinventing the wheel. There is plenty of libraries that can solve quite some problems. So use them wisely. There is a fine line. You don't want to reinvent everything, especially cryptography. In crypto is hard. Nobody understands it. There are mathematicians that do it. Then they talk to some programmers that are partially mathematicians, and then they write crypto libraries that nobody wants to maintain and understand and stuff like that. Don't try to reinvent your own crypto. You will forget something. But in general, if you are trying to solve some problem, try to figure out what libraries are there that will help you with the problem. And don't write everything again and again. Use what's already there. It will save you some time, and sometimes you get some nice features in the process. It has some downsides. When you are looking for the libraries, try to figure out whether those libraries are good for anything and whether they are still alive. There are quite some libraries that are dead already. Nobody is developing them, nobody is maintaining them. And to be able to compile them, you need hardware and software from 20 years ago. And it has to be full moon to compile it, something like that. Don't try to drag something like that into your code. And also, there are huge libraries that are really fun to use and that will help you with quite some stuff, like Qt or GTK. But don't drag them into your simple application just for really, really simple stuff. Sometimes it makes sense to actually reinvent wheel. If you need to just log something to syslog, it makes no sense to pull full Qt because of that. Another interesting point is when in Rome, do as the Romans do. Try to respect the style of the language that you choose to use and the environment around it. Try to respect the best practices that are for that language. And one thing that package maintainers will be really, really, really grateful is to use reasonable build system that is meant for your language. So if you are writing C or C++ application, please stick with AutoTools or CMake. Don't try to write your own build systems because you will definitely forget everything. Well, not everything, but you will forget plenty of use cases that people really need. Your maintainer of your software will actually have to learn your system. Then he will have to fix it. And by that time, he will be really, really mad. There are even worse stuff. I've seen one package. It's a C++ program. And they are using Node.js build system. And there are bits and pieces of Python inside as well. So don't try to get too creative with build system. If you are using some language, use what's typical for that use case. It will really help your users. It will really help your package maintainers and stuff like that. Now, the right amount of knowledge. So, do you know every aspect of your language? Are you expert in that language? Do you know how your OS is working under some minor some corner cases, all possible side effects of some operation, stuff like that, how to trick compiler to do something else that it isn't supposed to do. So it's good for you, but don't use it. Try to stick to well-known facts. Using everything that you know about the language and using all obscure functions of that language doesn't make you a good programmer. It just makes you a jerk, and everybody will hate you for that. And the software is then unmaintainable and will be thrown away anyway. So it's no point in doing that. Use the right language. Some languages are better suited, some you should avoid. So wrong language is the awesome language you just started learning, or you read a great blog post about. If you want your software to be used in production at some point, don't make it your first project in that language. First project in the new language should be some hobby projects that you are fine to discard and rewrite later, because you will learn how the language works during the process. You wouldn't make it in the first run the right way. Also, if you are working in a team, don't pick the language that nobody knows. That also basically just makes you a jerk, and nobody wants to work with you, and everybody will avoid your software. Nobody will help you, and at some point, there is in team usually there is more people than just one. So at some point, because it's your common responsibility, the people around you will basically rewrite the software in the language that they can cooperate in and get rid of the stuff that you patched together. Yeah, and let's skip the last one. The right language is something that you are comfortable with, and you can write fluently, and you don't have to look up everything. Great plus points is if your peers are comfortable with it as well. And at some point, you should look at what the language actually can do. So I wouldn't try to write a new web browser in Fortran or something like that. But yeah, if you know few languages, pick the most suited one for the job. Yeah. Optimizations. Another fun topic. You want to make sure that the part that the most time is spent in as fast as possible. When you are developing, you are going to spend the most of the time maintaining the code. So make sure that the code is readable, it's maintainable, you can debug it, and you can extend it. That's the most important, at least at the beginning. When somebody tries to use it, you are going to throw away big piles of the code anyway. So it's no point in trying to optimize it in the first place. Optimize it when you know that it's going to be used, not when you think it's going to be used, but when you are sure that it's going to be deployed, and when you know that there is a problem that needs to be solved by optimizing the code. And document the right stuff. Documenting the obvious is meaningless, but documenting the hard parts, yeah, sometimes documentation of the hard parts can be meaningless as well. I picked a few examples. In general, try to write code that is so clear that it doesn't need the documentation. if it needs documentation, think twice whether it could be written in some simpler way, so it could be understood from the first look. And at worst case, write a meaningful documentation and explain the hard stuff and why you couldn't find anything easier to do, any easier way how to do it. So, few quotes to end with. Always code as if the guys who ends up maintaining your code will be a violent psychopath who knows where you live. If you write a bad code, the guy maintaining your code will end up as a violent psychopath. There's just, he needs to figure out where you live. There's no question about the psychopath part. And another really important quote that I found is, debugging is twice as hard as writing the code in the first place. So if you write really complex code, you need to be twice as smart as you are now to be able to debug it. So try to write simple code, dump code that can be debugged and maintained by anybody. And it will help even you when you get back to your code in a few months' time. Thank you for your attention. I hope that some of it made sense. And if you want, we have a few minutes for some discussions. Otherwise, you can start leaving for different rooms, and people can come here for next session. So, any remarks? No? Thank you.